Let's look at this particular question. So it is toss a failed coin twice and record the outcome, the head as H, tail as T. So we will have the sample space draw down here. Let's try to first draw down the sample space by using the Venn diagrams. Okay, so we will use omega to denote the sample space. So we know that if we toss one coin twice, we'll get the two outcomes, and each will be using to denote by H and tail. So we have first scenario, which is head. Second scenario, which is the head tail. Third scenario, which is tail. And the last scenario will be tail, head. Okay. So once we list down all the possible scenarios in the sample space, we will try to resolve this particular question. So first we define three events here. Event A as the outcome contains no head. Basically, is this event TT. Okay? So this is event A. So we can write down the event A elements is TT. Then we look at event B. Event B mentioned that outcome contains two heads. So we're looking at the sample space. Only these outcomes contain two heads. So this is event B. So we can write down event B as HH. Next, we look at the event C. Event C is nothing but contain at least one head. So we will see for contain at least one head, we will have three scenarios, which is HH, TH, and HT. So these three events will form event C. So let's write down HH, HT, and TH. Next, we look at a more complicated scenario. We want to calculate the intersect and union of different sets. So first look at the intersection of event A and B. So you will see event A and B from this Venn diagram. Actually, event A is this TT, event B is nothing but this HH. Maybe I use another color. So you will see event A is this TT, event B is this HH. So you will see these two events are disjoint. We also call it there's no intersection between A and B. So the result will be empty set. Okay. Then we look at A union B. When we say union, basically means that elements is either occurs in event A or event B. So in this scenario, we will have two elements in A union B, which is HH from event B and TT from event A. So similarly, we can calculate for event A intersect with event C. We'll say what's the common elements of A and C. So we'll see that for C, it contains three elements HT and TH. For A, it contains TT. So they are still disjoint. There's no intersection in between. We also call this mutually exclusive. So their intersection will also be empty set. Now let's next look at event. Maybe let me erase this first. Now next, let's look at event A union event C. So we'll see that event C contains this HH, HT, and TH, these three scenarios. Event A contains TT. So basically, A union C basically is the entire sample space. Next, we look at event B interact with event C. From this diagram, we can see that actually event B is HH, which is a subset of event C. So their intersection would be event B, which is, we already calculated previously here, which is HH. And for event B union given C. Because B is a subset of C, the outcome will be C. So you will see this is B, this is C. So you will see the union will be C. So we also get a C here, HH, HT, and TH. And the last one is the C intersect with B. So this basically is equivalent to intersect with B and C because both is denoted as the elements occurs both inside C and B. So the sequence actually doesn't matter. So it is basically equals to B and C. We have already calculated here is H. So that is the solution for this question. This is a very fundamental question and hopefully that you can understand it.